Today we're going to do lesson 7.2, multiplying polynomials. Now, yesterday we learned about polynomials. We broke them down. We learned the different kinds. And yesterday we added and subtracted. Remember, I kept saying, look in the center of the two sets of parentheses. Is there a plus sign? Is there a minus sign? So today when we look at a set of parentheses or two sets of parentheses and we look in the center and we see nothing, what operation does that represent? Multiplication. Very good. Now, there is a method that we can use to quickly multiply polynomials if we are looking at two binomials. Now, think back to yesterday. What is a binomial? A polynomial that has two terms, right? So if you're looking at a problem and you're multiplying two binomials, then the FOIL method is going to be your quickest way. Now, let's talk about each of these letters and what they stand for. The F is your first term. So if I'm looking at this first set of parentheses, what is the first term inside?
X.
If I'm looking at the second set of parentheses, what is the first term inside?
X.
So I'm going to multiply X times X. And you notice I made them both blue. All right, now the O stands for the outside terms. And obviously there's nothing outside the parentheses, but we're talking about those outer terms. So X and 3. And you can see I made those purple. All right. The I stands for inside. Some people say inner, but I say inside. What are the terms on the inside of the problem?
2 and X.
Good. I made those, highlighted those pink, the 2 and the X. So we'd multiply those together next. And then the L stands for the last terms. And this one tends to trip people up. But think about it. If I'm looking at this set of parentheses, what's the last term inside?
2.
And if I look at this set, what's the last term?
3.
So I'm multiplying 2 and 3. Okay? So first, outside, inside, and last. Now, this only works, and I want you to add this note somewhere on your paper. Okay? Foiling only works if I am multiplying two binomials. If at any point I'm multiplying a binomial and a trinomial, okay, it's not going to work. Foiling only works if I am multiplying two binomials. So let's look at example number 1. Now the instructions give us another hint that this is a multiplication problem because it says find the product, and the product is the answer to what kind of a problem? Multiplication. So if you can't remember that, when you look and there's nothing between the parentheses, that it's multiplication, hopefully the word product will help you remember. Now look at this entire screen, and you're going to notice you don't have C and D on your paper. After I printed out your notes, I went back and added C and D. And we're not even going to get to D today, but we will add C here in a few minutes. But look at the whole screen in front of you. What are we multiplying in every single one of these problems? Okay, two binomials. So will the FOIL method work in example number 1? Yes. All right, so we're going to work through it slowly on letter A, and then we'll pick up the pace for B and C. All right, the F stands for first. So Gage, what are the first terms that I should be multiplying together?
X and X.
All right, I've got X and X. Now, with that being said, we've got to go back to the beginning of chapter 6, before Christmas, when we learned our exponent rules. When we multiply powers with the same base, what are we supposed to do to the exponents? Add them. So what is X times X, Gage?
X squared.
X squared. Very good. All right, Olivia, the O stands for the outside terms. What are the outside terms that I'm supposed to be multiplying?
X and
X
negative 4.
and negative 4. So when I multiply those, what do I get? Negative 4x. All right, Claire, I stands for inside. What are my inside terms? Yep, X and 2. Very good. So 2 and X. What is 2 times X? 2x. Very good. And then Alyssa, my L stands for last. What are the last terms that I should be multiplying together? 2 and negative 4, which gives me what? Negative 8. Now, in the majority of my multiplying of binomials, I'm going to, if I've done this correctly, I'm going to have like terms to combine. So we've got to switch gears. We were just multiplying, but now I have to look and I have to find like terms, if there are any, and I have to combine them. So if I've done this correctly, the like terms will be in the middle. They'll be right there together. So do you see any like terms in this problem that we need to combine?
Yes.
Yes, what are they?
Negative 4x and 2x.
Good. So we bring down the first term, we bring down the x squared. What do we get when we combine negative 4x plus 2x?
Negative 2x.
Good. So we switch back into what we learned yesterday and we simply add or subtract the coefficients. So negative 2x, and then of course we bring down the negative 8. So that is how you multiply binomials using FOIL. Now let's look at letter B. All right, Luca, what does the F stand for in FOIL? First, so what are my first terms that I'm going to multiply together? Okay, n times n squared, which equals what? N what? N cubed. N has an understood 1, n squared is a 2, so we add them together and we get n cubed. All right, Noah, the O stands for what?
Outside.
What are my outside terms?
N and 3.
N and 3, and when I multiply those, what do I get?
3n.
Positive 3n. Good. All right, Olivia, I stands for? Inside. What are my inside terms?
2 and n squared.
And so when I multiply those, I get
2n squared.
2n squared. Emma, L stands for what? What are my last terms?
2 and n.
And when I multiply 2 and 3, I get positive 6. Now, I'm looking for like terms. That's my next step. Do I have any like terms in this problem?
No.
No. So is this my final answer?
Yes. No.
Why not?
Because it's not standard form.
It is not in standard form. Very good. Okay, we learned yesterday our final answers need to be in standard form. So Alyssa, if we're going to put this in standard form, we don't have any like terms to combine. How do we put this in standard form? What is standard form? Right. The largest exponent down to the smallest. So for this problem, what does it need to say?
N to the third plus 2n to the second plus 3n plus 6.
There we go. We need to switch the 2n squared and the 3n, and then we can box in our final answer. All right? We've got n cubed, n squared, n, and then a constant. So that is standard form. Now, I want you to take a minute. I want you to add letter C to your notes, and I want you to work it with your partner. All right, Claire, the F in FOIL stands for what? First. So what did you multiply together first in letter C? Okay, so what is R times 2R? 2R squared. Awesome. All right, Gage, the O stands for?
Outside.
Outside, and what are my outside terms?
R and negative 1.
Which gives me, when I multiply?
Negative R.
Negative R, negative 1R. Esther, the I stands for what? Inside, and what are my inside terms? Negative 5 and 2R, which gives me what when I multiply? Negative 10R. And then Noah, the L stands for?
Last.
And what are my last terms?
Negative 1 and negative 5.
And when I multiply those, I get?
Positive 5.
Positive 5. Now, Emma, do I have any like terms that I need to combine? Good. Negative 1R and negative 10R. So I bring down the 2R squared. What is, Emma, negative 1R minus 10R? Negative 11R. And then I bring down the plus 5. So I have FOILed, I have combined my like terms, and my final answer is in standard form. Let's look at example number 2. This one tells me specifically what to do. It says use the distributive property to solve. Why can I not use FOIL on these two problems?
Trinomial.
It's a binomial times a trinomial. Very good, all right? And understand, on a quiz or a test, these may all be mixed together, so you've got to pay attention. If it's a binomial times a trinomial, FOIL's not going to work. You're going to have to distribute. Now, we're going to do a lot of arrows in our notes just so we have something to study, but you're not going to be required to draw all these arrows when you're working a test or a quiz, all right? But we're going to do it in our notes. Now, I like to distribute the binomial terms, Okay, you really could distribute the trinomial terms, but to me it's just easier if I'm only having to distribute two things. So I'm going to start by distributing the x in the binomial, which means I'm going to do x times x squared, I'm going to do x times 5x, and I'm going to do x times 8. I have to do it by everything in the set of parentheses behind it. So what is x times x squared?
X cubed.
X cubed. Very good. What is x times 5x?
5x squared.
5x squared. And what is x times 8?
8x.
8x. Awesome. Now I'm going to go back to the binomial and I'm going to distribute the 1. So 1 times x squared, 1 times 5x, and 1 times 8. Now we can continue this list horizontally if we want, and then we can find our like terms. It's kind of like what we did yesterday in 7.1. Okay? Or I'm going to show you the way that I like to do it that will hopefully speed things up a little bit. What is 1 times x squared?
X squared.
X squared. Do you see a like term for x squared already written down?
Yes.
What?
5x squared.
So what if I just put the x squared underneath its like term? All right, what is 1 times 5x? 5x. Do you see a like term for 5x?
Yes.
What is it?
8x.
8x. What if we put that 5x under its like term? And then what is 1 times 8?
8.
Do you see a like term for 8?
No.
No, so we just put it on the end. Now we can add our like terms vertically, and it should be a lot quicker. We bring down the x cubed. What is 5x squared plus x squared?
6x squared.
6x squared. What is 8x plus 5x?
13x.
13x. And what is, well, 8 doesn't have a like term, so we bring it down. Are we in standard form?
Yes.
Do we have any other like terms?
No.
No, we're done. So again, you can continue it horizontally and then go find your like terms, but this just makes a whole lot of sense and will make things a lot quicker for you. All right, now let's look at letter B. What are we going to distribute first, Claire, in letter B? The n. So we're going to do n times n squared. Again, let's do some arrows. N times negative 2n and n times 4. So what is n times n squared?
N cubed.
N cubed. What is n times negative 2n?
Negative n squared.
Negative 2n squared. What is n times 4? 4n. All right. What are we going to distribute next, Noah? The negative 3. So negative 3 times n squared, negative 3 times negative 2n, and negative 3 times 4. What is negative 3 times n squared?
Negative 3n squared.
Does that have a like term up there?
Yes.
Yes, negative 2n squared. So let's just put it under its like term. What is negative 3 times negative 2n?
Positive 6n.
Positive 6n. Does that have a like term?
Yes.
Yes, it's 4n. So let's line it up underneath its like term. And what's negative 3 times 4?
Negative 12.
Does it have a like term?
No.
No, so we just put it on the end. So n cubed. What is negative 2n squared minus 3n squared?
Negative 5n.
Negative 5n squared. What's 4n plus 6n?
10.
And of course, we just bring down the negative 12. Is this my final answer?
Yes.
Yes. It is in standard form. There are no more like terms. So that is how we multiply a binomial times a trinomial. Now let's go put this into a real life situation. Example number 3. It says the football field is rectangular. Now go back to 7th grade and tell me, how do you find the area of a rectangle?
Length times width.
Length times width. So letter A says write a polynomial that represents the area of the football field. So area equals, what is the length of this football field?
10x plus
10x plus 10. So we're going to plug in the binomial 10x plus 10 for L, the length. What is the width of this football field? 4x plus 20. So we're going to plug in that binomial for W. And there is our area of this football field. So we box it in. That's all it asks us to do for part A. Now look at part B. It says find the area. They want us to actually find the area of the football field when the width is 160 feet. Now I've given you a hint. We've got to solve for x first. If we go back and look at part A, we have two unknowns. Our area is unknown and we have this x value. So we can't solve for area unless we know what x equals. And they've just told us that the width is 160 feet. So what's the equation that we can write in order to solve for x?
160 equals 4x plus 20.
There you go. All right, the binomial 4x plus 20 represents the width of the field, and they just told us what that equals. It equals the 160 feet. So what would I do first to solve for x?
Subtract 20.
Good. I'm going to subtract 20. So that leaves me with 4x equals 140. How do I solve for x?
Divide by 4.
Divide both sides by 4. So what does x equal?
35.
35. And we are going to circle, don't box, because that's not our final answer. They didn't ask us what x equals. They want us to find the area of the football field. Now, once I have the value of x, what can I do with it so that I can actually find the area? Go plug it into that area formula. So I'm going to bring that down. It was area equals, or A equals 10x plus 10 times 4x plus 20. So area equals, we just found out that x is 35, so I'm going to plug that in place of x plus 10. However, we already know what 4x plus 20 equals. It told us. So instead of 4x plus 20, what can I put in that second set of parentheses?
160.
160. All right, good. Could you plug 35 in and leave 4 times 35 plus 20? Absolutely. You get the same answer. But why do the extra work if we don't have to? Okay, so in the parentheses, we're at 10 times 35 plus 10. Well, what is 10 times 35? 350. Good. Plus 10 is 360 times 160. Now use those calculators and somebody tell me the area of this football field. 57,600. And since this is a word problem, we put our units, which will be feet squared, because anytime we find area, our units are always squared. And that's how you use polynomials and multiplying polynomials in a real life situation. And that is lesson 7.2.